Hey guys, welcome back. Last time we tried to add two numbers using a reverse order linked list, and this was our solution. If you want to learn more about the solution, please go check out the previous video. Um, and what we essentially did here was that we created a loop which was always true, and we exited out of the loop using this condition, and we initialized sum to 0 at each iteration, and then added the value of node 1 and node 2 to it, and then added the carry to it, and then saw and then figured out whether we will have a carry for the next node, and got the ones digit of our sum here, and then we basically added that sum digit to as the data for our result or return node or linked list. And then we had some error handling stuff down at the bottom of our while loop, and that was basically how our function was able to sum these two linked lists in reverse order. Now let's get more creative and think about whether we are able to add the numbers of two linked lists in forward order. So this time, actually, it gets even trickier, because we might not be able to add two linked lists that don't have the same length. And the reason for that is that we don't know the lengths of our linked lists beforehand. So we are not actually able to align them like this, like the one that we draw here. So if we wanted to align them, it would probably look something like this, right? It would look something like this, which will be arithmetically wrong if we try to add the numbers that are in under each other here. So that is not alignment. That is not mathematically right. So we would want to suppose that our users are always going to provide us with two linked lists that have the same length. All right. So with that, let's write down another example. So maybe 4, 5, 6, and 5, 6, 7. All right. And this should return something like this. Should return 7 and 6 are 13. And let me actually write this down with another color. So these are 13, 6 and 5 are 11, and 4 and 5 are 9, which with that one will return that. And this should be how our linked list, our result linked list, looks like. Okay. So we basically are still going to calculate our result from the ones digit, but how are we going to do this in one pass and still have that O of the length of the linked list, so O of n, and only traverse through the linked list once? So we can use something called recursive functions, and the way they work is that we have a function, and sometimes in recursive functions the function doesn't have to resolve when it's called, so it can call itself and wait till its recursive call is resolved, and then use that data to resolve itself. And like that recursive function could also call another recursive function, and that could also call another recursive function. So we could have a chain of recursive functions that will wait till we hit a base case, and and the last recursive function is resolved, and that will help us to resolve all the previous functions. So then we can go up the chain that we just created. Okay, and then we are able to return the final result here. So we will do something like that. At least that's the goal. So let's think how we can do that. So we would probably have a function that receives node 1 or number 1 and node 2, right? Node 1 and node 2, and probably our carry digit. Do we want to pass the carry digit here? Let's have it, and if we didn't use it, then we'll remove it. So node 1, node 2, and C for carry, right? Let's see what we can write inside this function. So first we want to do what? First we want to have a base case. So what will happen at the very end? So at the very, very end, the thing that happens is that n1 dot next and n2 dot next both will become null. This is not 100% correct programmatically, but you get the idea. So both of these return null. Okay. At that case, and only at that case, we will want to call the function itself again. Okay, so let's do that. So if that was the case, okay, then do this. Then define a variable called sum and assign n1 the data plus n2 the data to it. Alright, cool. We do that, and then we will create a new node. So we will say result, and it would be a new node, and we will assign the value of sum to that. Okay, so that is it. This is our base case. So let's wrap it in a pair of curly braces. So that is it. Else the function is called. And how is it called? So if we want to call the function again, we will just call its name, and we will pass it this time n1.next as well as n2.next. Okay. n1.next and n2.next. And we're not still sure about carries. I'll just leave a room for it, but we'll see if we need to do that. So basically, when this function runs, it will skip the if statement, and it will call itself over and over and over again. All right, and then So what we expect this to happen at each iteration is to return the result of the next node, right? So let's say that returns so this is our next node, right? So right now we were able to call the function itself over and over again, and this is now resolved. Okay, so this is resolved, but how would resolving that help us resolve this? So this then has to be, so I would extract carry from here and set it here to 0. Would I have to do that? Probably not. No. So first time this happens. The second time, the result of that, would be stored, would be the result of our next node. The data inside of our next node, or no, the node. So it's still returning a node, right? So that's good. Now, so this is a node. This is the next node. So we would want to do this. We would want to create a new node, and inside these parentheses, this will be our next node, right? Which we are pointing to it. And for our current node, we have to do some calculations. And for our current node, we would want to, so let's call this, I don't know, XXX. Right? So we have that. And we would say XXX is, okay, it's the sum. So let's call it X, instead of XXX sum. So again, sum, and sum is first 0, then we add carry, then we add n1.data, and then we add n2.data, right? So let's take a look at what we have so far. Okay, so this is what we have. So we are calling the function again and again and again inside this. And the trickiest part is that we'll have to have the carry from the previous function somewhere, right? We don't just need the node itself. What happens if we have a carry? Then our function has to give us a carry somehow. And how is that? That's the main issue here. So sum is 0. And we add the carry to it. Where is carry defined? Let me change colors here. So we are able to hit the base case. We are able to get the value that we are going to put inside that node, and we are able to return it and store it here. But then at next iterations, we are still able to calculate their data. That's okay. Right, so we postponed this part till we figured out this part. Right? So that's all good. Okay, so what we can do is to just have this somewhere and have a reference to it like the next node, and then do the calculations with the next node here, right? So I think I now have an idea of how I want to do this. So without further ado, let's jump into the code, and I'll try to keep it quick and try to solve the problem as fast as I can. So let's see how I do. So I'm not going to touch this. I'm going to create our new sum method here. So public sum forward, public static, and it returns a linked list node, and it's called sum forward, and it receives two linked list nodes of n1 and n2. And here, so remember, we have to have a base case. So the base case is if n1.next was no, and if n2.next was no, then what we want to do is to basically go to our base case here, which is this one. We can avoid using these curly braces. Yeah, we can avoid them. We can just say that we are returning a new linked list node with a value of n1.data plus n2.data, and it doesn't point to anything, so that's all good, right? Then what we do is that we basically store that value somewhere. So I'm going to call var result next, and I'm going to call our function, and I'm going to pass it n1.next and n2.next. Okay. And so I have reference to that. Cool. Now I am going to do this. I am going to say if basically most of the logic that we had before, so I'm going to apply many of the logic from here basically. So we will have a carry digit here and a sum digit. So why don't I actually copy over most of these? Yeah, let's do that. So sum is 0, int sum is 0, or let's initialize it to carry. Do we have the carry? No. So let's calculate. Do we want to calculate carry here right now? So carry is currently 0. And if I calculate it before anything, I'm calculating it from the next node, which is our ones digit, which is okay. So let's do that. This time we are doing it in reverse, so that doesn't matter. So let's calculate carry. Carry is of type int, and we will math.floor sum divided by 10. And what is sum, you might ask? It would be this. And we will then say that and then we will say that result next data should be changed to result next data modulo 10. All right, and then we will say that now we will go to calculating our own the sum for this current node, right? So we just fixed the return of that recursive call. Now let's go and get the sum. So sum is an int, and it's initialized to carry, which could be 0 as well. So sum plus equals and one.data, sum plus equals and two.data, right? And then we will say we are returning a new linked list node, which has which is pointing to, which has the data of sum, and it's pointing to result next. Yeah, I think that's it. I think this should work. Do we have any unused variables? No. So this was sum reverse. Now let's do sum forward. Let's try our example 4, 5, 6, 5, 6, 7. So remove these two. Remove this. We can't do that. Sorry. 4 and 7, 6, 5. Okay, good. Now we will call sum forward here and pass it node 1 and node 2. And store its result here and print it out the line below it. So what is the issue? Main.java line 32 over here. What happened? If both of these were null, because n2 is null, how is that possible? Both of these have the length 3. What? Why? Let's write it again. 5, 6, 7, and then no. And how about n2? 6 and 7. And we're not going... Sorry, what happened for the previous one? 5, 6, 7. So 5, 6, 7 is for N1, right? Am I passing? Oh, god damn it. Note 4. Sorry. Okay. Hope this works. 10 to 3. So 3 to 10. That 10 has to also be checked for. So we have to check the sum once more. So what we want to do, if we want to like cover all the edge cases, if sum was greater than or equal to 10, right? If that ever happened, sum wouldn't go beyond 19 at the worst case, right? Because imagine the worst case. The worst case is that we have a bunch of 9s. 9, 9, 9, 9, 9, 9. So 2 9s would be 18. 2 9s would be 18 with that 9 would be 19. 2 9s would be 18 with that 9, 19. So it wouldn't reach 20, right? So what we can do here is to always carry 1 if that ever happens. So we will create a new linked list node here. And I'm going to call it something like... what? Result carry. And I'm going to create a new linked list node that has the value of 1 and is pointing to our current node. Okay, so I'm going to call this, then I'm going to create that somewhere else. So I'm going to say we have a result head. We have a result head, and that result head is this. And then this will point to the result head. Okay. What's the problem here? Declaration is not allowed here. Declaration is not allowed here. Is that allowed here? Okay. Return. That's a good question. Return. I would want to say result head. Maybe I can just say it like that. Right? Can I do it like that? So hope that it works. Whoa. Whoa, whoa, whoa. What just happened? What just happened? If sum was greater than or equal to 10. So if we added all of these and we got something that was greater than or equal to 10. Okay. Okie dokie. Okie dokie, okie dokie. So if I just comment out this all works good, but if I do this, so let's say okay.
It's 4 o'clock.
Okay, so what I would want to do here is to I don't know really. maybe to... Yes, the problem is that we sometimes we are not editing the value of the node right away. And that completely makes sense to me. And then we are editing the value, like trying to create the carry outside over here. So how are we supposed to get that value for the last node? So that would... We have to become smart here and detect that we are at last iteration. But how? How? Alright guys, so I think I might have the solution to this issue that we were seeing, that the final carry, that we are not able to detect the final carry, and add a node and replace the head basically with a more appropriate one. So the way to do this is to have actually two separate methods. So one for the recursive call and the other that wraps around the recursive call. So I'm going to call this recursive call now something else like recurse sum forward, and I'm going to create another method here, and this will also return a linked list node. So we want to match the return type of that with this recursive function, so that we want to, when we call this function, which I'm going to call sum forward as well, so we are now calling this wrapper kind of. So when we call that, we want to make sure that it still receives a linked list node. So, and it will accept the same set of inputs as that one, so that when we call it here, whatever we pass it is easily transferable to the recursive function. So that's that. And now inside here, what we do is that we call that recursive function. So recur sum forward, and we pass it n1 and n2. So we're basically calling this wrapper function, and then inside that we are calling the recursive function, right? And after that we want to receive its results somewhere and store it somewhere. So that would be temp result. Okay, I'm going to call it temp result. This is temporary. We might change it, we might not, we'll see. So this is the head of this linked list, right? So I'm going to say if, so if we look at here, you see, this is the head, right? This is what this function over here is returning. So I'm going to say if temp result dot data was greater than or equal to 10, so if it was a 2-digit number, then we want to do a certain set of actions, and one of them is to just change temp results data to temp result the data modulo 10. So we want to get whatever is inside that data, whatever is inside the previous hit, and we want to divide it by 10 and get the remainder, which would be the ones digit, and then we would want to store that inside the temp data instead. And since, as we discussed, the total value of this, like the total carry, cannot exceed 1, we can safely only add 1 to the beginning of our result linked list. So, and that would be correct. So what we want to do now is to return. If we enter this if function, we want to return if block, we want to return early with a new linked list node, and this one would have a head of value 1 and it will point to temp result. And the value of temp result, if you remember, is now updated. Now, if we didn't enter into this code block, that means that everything's fine with temp result. So we would just want to return temp result right away. So we'll do that. So that should fix our issue here. So let's run this and give it a shot. So yeah, as you can see, this is working correctly. So if there is no carry, it won't create any new nodes at the beginning. And if there is a carry, it will create a new node, just like the previous example here. So 4 or 5, right? So it will create a new node. So, and it's not altering our input, right? Our initial linked lists. So with that, I'll wrap up this video and I'll see you in the next one. Bye.